for me.
Nathan, are you there? Am I audible, class?
Your voice is breaking a lot.
Class, am I audible?
So your voice is breaking a lot.
I'm audible now.
Yes, so now you are audible.
Okay. Can you check now if it is being restored? Being restored now?
Yes, sir.
Being restored now?
Yes, sir.
Yes, Nathan, you didn't respond. What happened?
Sir, yesterday during the class itself, it took down the notes. So I thought that much was sufficient. So I didn't think it was necessary to message you for the notes yesterday.
So that'll be the order, I think, that was categorically mentioned, right? Right, Nathan?
Yes, sir.
The order will be execution that very day, and it was categorically mentioned. Correct me if I'm wrong.
Yes, sir.
Yeah. So in that case, whatever be the situation, you're supposed to get done with the work day on that very day. Is it clear to class? Is it clear to class?
Yes, sir, very clear.
Yes, sir.
Yeah. All of you, those who are listening to me, there are as of now how many? 24, 25, how many are there? You are supposed to get done with it. If not, next class you will not be permitted. I think I've been well received, correct?
Yes, sir.
Yes, sir, very
Next
well received.
class there will be permission to only those who are interacting. Those who are not, I'm least to continue with them. Clear? Is it received well, class?
Yes.
Yes, sir,
Yes,
yes,
sir.
sir.
Yeah. Okay, so today we are to further with what we were doing the other day. If you have anything else to ask, please come up with it. If not, we'll be furthering with what we took yesterday. Anything that you are to ask? Anyone?
So, what do we have to send a message for again?
You are to send message on daily basis of the working taken that day with the other batches so that 3 to 3.5 hour class can be done in half an hour with you. When we are dealing only for half an hour. There are many ancillaries to the topic that we will be taking in that half an hour. Those ancillaries cannot be taken, but you should be aware of them. Therefore, if a class is positioned on that day, it will not happen on an everyday basis. But if the class were positioned that day, I'll ask you to connect and accordingly take the notes. Getting it?
Yes, sir.
Or if I'm having with me in manuscript, generally I do have the manuscript of those. So those are to be passed to you if deemed fit. But there should be an ask from your end. That is on my relation, I'm to pass or not. Asking is certainly to be from your end solicited every other time. Clear?
Yes, sir.
Okay. Now, if you don't have much to ask, I will ask you certain question on the topic that we were dealing. And the question
Sorry
you
to,
asked, yeah, tell me.
I'm so sorry to interrupt. Could you please send your contact information or something on the chat?
You can request someone to get you, okay? Yesterday I shared. You shall be
Okay.
prudent enough to record. If not recorded, ask for help. Someone will help you on this, okay?
Okay.
Now, whatever asking you to do is get me know on what you want. If you are not aware of what you want, if the class is not in consonance with what they want, because there should be unanimity on what you want before of joining that any day that we are. If it's not being done, then let's try to get done with few terms which I have decided myself for the day, and please keep to the time class when you're joining. This way, if you keep on joining, will not in any way work with me. So please keep to time. Initially, you're getting some leeways. This will not be the order of day. Okay. Look at the board which I am depicting to you. Tell it's visible or not.
So I think it's sideways.
It's come again.
So I think the board is like sideways for me.
Okay, good. Check on visibility now. Good.
No, sir, the board is sideways anyways.
Sideways means orientation should be changed to landscape or what?
Yes, sir.
Okay.
Yeah.
Okay. Check now.
Yes, this is good.
Yes, sir, this is better.
Okay. Then we write down all of you. Given a rod as shown in figure, carrying current I, kept in magnetic field B, experiences force. Someone will tell me what will be the direction of force, class? Upward. Experiences force in upward direction. Subsequently get displaced. By an amount dy. Subsequently get displaced by an amount dy. Does this experiment prove work done by force F? Does this experiment prove work done by force F? You have to tell me, is this equation to qualify statement which I am in making? And that being, force F did work here. Yes or no?
So can you repeat what you said?
Come again.
So what did you say, the last line?
Is my statement to be accepted by you, or in negation you are to it? And the statement which I am in making is force F did work.
So are we supposed to say if we agree or disagree?
Yes. With
Okay.
total evidence vindicating it. There should be some reason to either support or negate it. Yes, please. Because we are coming to a conclusion. We'll draw an inference from whatever you are into making. And that can be a departure from whatever you have read till date. So exercise caution, please. F is I into L cross B. And what about F we can say? Is F doing work or not? Yes, we are aware of F will act in which direction? Upward, as you did indicate, someone did opine, and the person is correct. F is given by, you're aware of formula. And accordingly is upward. There is a force in upward direction. This rod get displaced by a certain distance in upward direction under the application of this force. Yeah, there is a source should be connected to it for current to make flow. We are to make flow current in it. So for current to get established, for current to make flow in it, we are connecting it with EMF that is externally connected to rod. The rod experiences a force going to B field being present, and then force is everything to do with current LB. And also not to let the angle left, angle between L and B. You're aware of force direction. You're aware body getting displaced by certain distance in the direction of force. Accordingly, with what we carry as baggage on work done from work energy power chapter, what you are to comment? Work is being done by F or not? Quickly, class. Yes, Aniket, what is your take? Aniket, what is your take? Those who are joining now will not be allowed. It's already 13 minutes up. So I'm denying. Aniket, what is your take? Aniket, can you hear me? Yeah,
So
please
can I
share.
answer?
So my bad. My mic wasn't working. I think, yeah, it
It
does.
does. Adi, what is your take? Adi, what is your take?
Yes, sir. I think work should be done.
Okay, Baba, what say you?
Sir, it does work.
It bus too, right?
Yeah.
Sir,
Agastaman, what's your take?
Yeah, sir, it should.
Okay, someone is calling on me. Yes, who is it?
sir, can I? Sir,
What's your name, dear?
I, Om.
Om Yao, please go ahead.
Sir, I don't think so. It is doing work. So because we have studied right, magnetic field cannot bring a change upon the kinetic energy of an electron.
See,
And what is happening?
whatever you have studied, I am not going to circle on those. I am to ask you based on your knowledge. What you study is not to be parroted, right? It's
So
not
wait.
axiomatic. It's not
So
axiomatic. You need to prove in science. Correct?
okay, Okay, sir.
Yeah.
Then I can tell it this way. My electrons are going from A to B. And
Hmm.
if we look at macroscopic level, the magnetic field is not really acting on the rod, but it is acting on the individual electrons. Since the displacement of the electrons and the force acting on them is perpendicular, um, there won't be any work done.
So the force acting is perpendicular. What about this force? From where is this coming? It is not coming from nowhere. It is coming from B field application, correct? Are you of the
Yeah,
opinion that this force is from somewhere else being sourced, not on B? Is it so?
no, sir. What I'm saying is this magnetic field is only providing the source of the force. But then, if you look at it properly, this force is the accumulation of all the tiny forces acting on each individual electron. Since my current is flowing from A to B, but my force is upwards, so both of them are perpendicular to each other.
So, own current, you mean to say, what I'm understanding of you, your what you have opined is electrons are not flowing in this direction. Positrons are not flowing
They're,
in this direction, aren't they?
they're flowing from B to A, but yeah,
Yeah, electrons from B to A, positron from A to B, or the positive counter of electron as we know, anti-electron from A to B, correct?
correct.
So they are flowing from A to B.
They are
And
flowing
they're
from A
flowing
to
from A
B.
to B. Yeah, please?
Yes, sir, you're correct. They're flowing from A to B, but then the
Yeah.
forces acting is perpendicular to them, right?
Yeah, force is acting perpendicular to flow for direction of velocity, correct? So force is acting V cross B, that will be upwards.
Yeah, so there should not be any work done, right?
You're asking me, you're pointing it back to me. My question being, there's a force acting on this rod. Are you in agreement with it or not?
There is a force, yeah.
And owing to that force, under the impression of this force, it gets displaced by dy. Are you in agreement?
I am in agreement.
So if you concur to it, as per what we are known about work, work will get done by F, correct?
Yeah. Yeah.
You're making an exception over an odd. Why? Because you want to go ahead with what being taught in class, right?
Now trying to relate it with it.
Yeah, you try not trying to relate it. You are trying to use reverse logic. Okay.
Okay. Yeah.
Yeah. So don't do that. You need to think about it. If you want the answer, I do have description for this, but have never occurred to you, then should give a thought to it. What do you want? A discussion?
Yeah.
Just because you
Yeah. A
want to
discussion
thought
on this.
on it?
Like
Uh-huh.
a differentiated.
If you want to egg on, I'll give you time. You can buy time, and we can get back on this. Because I had few questions, and those
Okay.
questions, I think those who did ask me about notes, they must have got those questions. I made the class write those questions. I also asked one, is
Yeah.
B field that we are referring to, the field that I'm referring to, B field, is that conservative in nature? Those were the questions asked. So you should have by now circle on this. Oh, I think you do have, correct?
Yes, yeah, you did send the notes.
Yeah, correct. So you did ask Courtney, I did share with you. You're on the right
Huh.
side, let me tell you, okay? You're on the right side.
Okay.
Of course, I'm not to make any departure from whatever we have studied, though we don't have reason for it. We need to reason it out, and that's the purpose. That is part of the course, this association, correct?
Correct.
It's not just to be accepted the way that being served to you. You need to understand what goes into it. Because there can be many questions which can be positioned on it. You know why? Let me ask you
Why?
another question. You can position on this mechanical question, which is based in mechanics. This is what is given to you, and there's a block on it. There's force which is acting this way. Okay.
Yeah.
Normal when you walk this way, right? Normal
Right.
can be broken into two component. One is this, the other is this, right?
Right.
If I take this component of normal and the body is moving up, then I can ask you that normal is doing work over here, right?
Yeah, you can say that.
If this component is being taken and the body moves along the inclination, but there will be some displacement, some shadow of that length in the direction of normal, which I have taken acting vertically upwards, then that normal or that component normal will do work, right?
Yeah, that component will do the work. Yeah.
Yes, that is what is important over here. So I think you can play on hunch now. Okay,
So, matlab,
that
no,
component is doing work. You're looking for one component. We are dismissive of the other component. If I'll find
hmm.
work done by this component and add them, that'll get me zero.
Yeah, makes sense.
Okay, so here as well, when I'm referring to force, you'll have to think about what is the direction of velocity. See, as it was moving in this direction, the anti-electron, it was moving in this direction. There is no two way about it.
Yeah.
But you gave this rod a motion upward, correct?
Correct.
Therefore, direction of motion of electron will now be this way,
Oh,
correct?
yeah. That makes sense. Yeah. Yeah.
Yes. So that is direction, and we are aware of to velocity, it will stand perpendicular. So force will be this direction. That is a given, right?
Huh.
We calculate for work done by only one of its component, which is what gets us something which is certainly non-zero. Of course, it will be non-zero, correct? As you
Oh,
got
yeah,
over,
it'll be
as
non-zero.
you got over non-zero, correct?
Yeah. Because
When
when
you
we're
take the other
talking up,
component into account, you do the exact work in the opposite direction or with negative sign. Okay, we can prove that. Therefore, this work and this work will get me a zero. So that can be proven. Fine, we know that. We'll be able to prove it. Getting it home?
okay.
Getting it home?
Yes, sir. Yes, sir.
Yeah. So work done by F will be zero. We'll be able to prove work done by F is zero. Fine. But there is an element which is doing work here, right? As there is an element, this F is doing work. They are going to F. This block will start moving up the inclination, correct?
Correct. Correct.
So F is doing work over here. Similarly, as battery is connected, there is a field which you have generated. that field is doing work, correct?
Correct.
And that work we can prove will be equal to whatever you're getting over here.
Acha. So we can look it at the perspective of the work done on.
We can prove that ILB into dy is nothing but work done by battery. It can be proved.
Okay, sir.
But that is
So base.
not work done by F. Work done by F will be work done by this component, work done by this component, and I'll sum up to zero. Yeah?
No, sir. What will sum up to zero? The work done on
Work
individual electrons.
what will sum up to zero over here? What will sum up to zero over here in the case of normal? Work
Yeah,
done
here
by
normal
this
will to
component
zero.
plus work done by this component. That'll sum up to zero, correct?
Yeah, yeah.
I'll not solve this for you. I'll leave this for you. So let's solve this for you. So that you can draw parallel.
Yeah,
Or
fine,
what do you
makes
want?
sense.
What do you want? Whichever you want. We'll go ahead.
I think this EMF thing is new for us, so that'll be better.
Okay, EMF you want?
Yeah.
Okay. Tell me what is force on it. We know ILB, this angle, let's say as theta, right?
Okay.
So what do we get this as? F cos of the angle theta. We get this as F sine of the angle theta, right?
Right.
And we know that any charge you take over here, they are moving with constant speed, drift
Yeah, the
speed.
velocity. Yeah,
So F sine of the angle theta should be equal to how much? Force on the charge, right? Isn't it? For constant speed, for acceleration to be zero, force in this direction should get annulled. Yes or no? Should get neutralized.
yeah. Yeah, it should
Agree?
be null. Yeah, it should. Yeah, yeah, correct.
If it's still annulled, then F sine theta should be equal to how much? E into capital E, right? E the field, electric
So no,
field.
but you're saying the velocity is constant, so there shouldn't be any force, right?
Yeah, there shouldn't be any force. Force should get neutralized. F cos
अच्छा
theta
ठीक है.
this should be equal to QE because E is already set by cell. Correct?
हाँ हाँ yes sir.
So we get from here F is equal to how much? On charge. Now talking of, as you did indicate, you are taking electron. So what will it be? EBB sine of the angle theta is equal to EB. Agreement? You confident
Yeah
to this? Okay, if you
yeah
confident to
yeah
this and this gone, right? What we
yes
end up getting? VB sine theta is equal to E. Right here. Right class?
right yes.
Now let us calculate work done by F cos theta and work done by F sine theta. What will be work done by them, right?
Right.
Calculate it. Work done by F cos theta, how much? F cos theta, right? F cos theta, and how much is this V, right? V means combination of VD and U. Getting it? Resultant. Getting it? Getting it? Am I
Yeah fine yeah
audible?
yeah
So F cos theta into what will I? V sine of the angle theta into dt, correct? Length?
no can you
In
repeat
time
this point?
dt? Length in time dt, agreed?
अच्छा हाँ yeah
Okay. This is work done by which component? F cos theta, right?
yeah in the up direction yeah
What about work done by this component? It is backwards, right?
right
And what will be the value of length against which it will do work? What is this for me? This is theta for me. So it becomes V cos theta, right? Check it out. U is V sin theta and VD is V cos theta. Agreed or not?
VD is V cos theta yeah
So work done by F sin theta how much? F sin theta, negative sign backward, and how much multiplied with V cos theta dt. Aren't they equal and opposite?
Yeah, they're equal and opposite.
Right? VD into D. VD is marked as V cos theta. U is marked as V sin theta. Check over here. UT is actually what I have taken. F cos theta will be multiplied with UT and F sin theta will multiply with VD into T. Clear?
Yeah, yeah,
U is F sin theta, V sin theta and VD is V cos theta. Clear?
clear.
Place them. What do you get to see? This is positive, this is negative, right?
Yeah.
Added will get you what work? 0.
So the answer is 0 for this.
Added will get you what work? Force should always get you work 0. That is what must be proven, right? Force will get you, this force got you what work done collectively. This force got you work done equal to how much? This plus this, which is to get you 0, correct?
Correct.
Okay, so we just proved that this force is not doing work.
ठीक है.
Okay, that was the conclusion, that force is doing work. What did we come to conclude?
This
We
force is
came
not
to
doing
the
any work.
conclusion that the force is not doing work, correct?
So, but I have a doubt here.
Just a moment, let me complete. But the work is being done, right? By F
Yeah,
cos
work is
theta.
being done.
Yeah, F cos theta is doing work. You are aware of it, correct?
Yeah.
What is that work? Try to figure it out. F cos theta, right? Into how much we have to write? This term, V sin theta dt is what we have to write.
V sin
V
theta
sin
dt.
theta dt. This is the work that we were skeptic of. After all, it is moving. This work is to be done by someone. Okay, this work is not done by F, but some element should do this work, right?
Okay, so you're saying a component of F is going to do the work, not F.
See, component of F is a vector quantity. You cannot say that the vector is doing work. Okay? So I spoke about vector. Vector is not doing any work. You cannot take a vector in components and say that work is being done by the component. When you talk
So, but
of
then,
vector, when you have to take all the components related to vector in order to comment on vector, right? You cannot
so but
say
then,
over here that function of normal is doing work. No.
yeah, you can't say that.
Okay. So it is being asked on what normal is doing. They will not ask you what is the component of normal doing. Of course, component will always do work.
So I
Okay.
have a doubt.
Now the question being, if it's not doing work, right? Here that work was done by which force? F force, right? This one, because the body moved up.
Yeah, yeah.
Here also the body is moving up, correct?
Correct.
So which element is doing work is the question, right? And that is what we are trying to figure. Which element is doing work? What is this? This I am getting as work, but it is not done by F. If it is not done by F, then which element is doing this work, right? Got my predicament? Which element is doing this work? Getting it?
So, just to be on the same page,
Yeah.
there you wrote V cos theta, F cos theta into V sin theta dt minus F sin theta V cos theta dt. So there what we are saying is that the force F, the total work done is 0. So we proved that.
Correct.
So, but
Correct.
then
Whenever
again,
we be asked a question, it will be always asked on vector here. This vector is doing work or not, okay?
no, sir. Okay, yeah, yes, sir. I understood. Sir, let me continue. Sir, then you wrote V cos theta V. Sorry, my bad. You wrote F cos theta into V sin theta dt is doing work, but F cos theta is the component, right?
Exactly. That is what it is camouflaged here. It is being
Array,
occulted.
sir.
I
But then you're
want to
saying,
know. I'm saying that yes, that component is appearing to me that the component is doing work. There is work done. There is no two way about it. But is it the component which is to do work or something else is doing work over here? Is it that over here you will say component of normal did work or will you say F did work? What will you say?
F did work.
Yes. But appear to me what? Appear to me that component is doing work, correct? Which was incorrect.
Correct.
We prove that the work done by component is actually work done by F. Okay? We can prove that work which is appearing to be done by the component is exactly the work done by F. So what normal does? Normal simply what it does is it is getting the force deflecting. It is getting the force deflecting. Now, if the force is getting deflected, then appears to me that normal is, but I know that normal cannot do work. That component is doing work. I cannot deny. That is some up there for me to make an observation on. But what is appearing to me is far from reality. It's not that the component of normal doing work. We have just proven that normal cannot do any work. We have just proven that force cannot do any work. Appearing to me is
Okay.
component of force doing work. Then I have
Yeah.
to prove that this work is being done, but it is the component which can do work. No, the component cannot do work. So what is doing work?
Yeah, what is doing work?
Exactly. That is what my question. What is doing work? Now, what is doing work? Look, E is the force, right?
हाँ ठीक है. Yeah,
E is the force. Distance moved how much? BD into dt, right?
right.
Okay. E is the force. Distance moved BD into dt. E is the force. BD how much? BD how much? B cos theta.
B cos theta.
Okay. B cos theta dt. Yeah.
So no,
Yeah.
sir. No, I have a doubt.
Wait
Sir,
a
but
minute.
V.
This is fair or not? I am calculating what is work done by field. Will you allow me that?
Yes, I will allow you that.
Okay. This is force on charge. Agreed.
हाँ ठीक है
Agreed.
sir. हाँ sir.
This is the distance moved in dt time. Agreed.
Agreed.
Force multiplied with distance in that direction. Work.
No, can you repeat?
Force multiplied with distance in that direction. Work.
Yeah, fine.
That is work done by which force? E. Correct.
Correct.
Good enough. Also, we know from this equation that EE can be replaced by F sine theta.
Correct.
Let us do the needful. F sine theta, V cos theta dt.
Oh, yeah.
This is what you got here. Yes or no?
Hmm.
Yes or no? What happened here?
Yeah.
Yes or no? This is what you got here, correct?
Yeah, we got that.
So, this work which appeared to me, being done by F cos theta is actually being done by, come on, complete my sentence. Is
By the
actually
electric
being
field.
done by-
Electric field.
Actually being done by?
Electric field.
Yes. Is actually being done by electric field. Yeah?
So
Yes, dear.
in the
So I have a
starting part,
doubt.
Yeah, one at a time, please, quickly. Tell me.
So technically, okay, sorry, here you go ahead.
yeah. So in the starting part, you had told that the electrons are the positrons are moving in the A to B direction. Can you explain the force components part once again? Like,
It was moving in this direction.
yes,
There was a speed which was associated with rod.
yes.
We added them. We got net direction of their motion, which is this.
Right, so there was a force in the upward direction, right? So
There was a force in the upward direction, which is what appeared to me, and that force is in actuality component of F.
okay,
As you have component of normal here, so is the component of this force here.
okay. So ILB is the component of a force.
ILB, no, ILB will be Vx is equal to q into v cross b will be this one. That will always be perpendicular as per the formula. Perpendicular to net velocity, correct?
Yeah.
So the force that we were referring to is component of QVB. Okay?
Okay.
With that QVB cos theta. Clear?
Okay, sir.
Sir, I
That
have
is
a
QVB
concern
cos
here.
theta. Yes, please. Yes, one.
So normally, whenever we do questions based on a moving rod in a magnetic field, we never consider कि the net motion is like this, right? We always consider कि my electron, my current ऐसे जा रहा है, तो मेरा force भी ऊपर की तरफ होगा. We never do all this component and all, right?
See, when we are referring to movement of electron, right? Electron will experience force in which direction? We are aware of it, correct?
हाँ जी, हाँ जी.
An electron will get deflected in that direction. It's not for the electron to rule the roost by stating I'm not to get deflected. It will get deflected in that direction.
Okay.
Okay? So it is ought to. There is force on it, it will get deflected. And if it's getting deflected, then you will next go for not the direction which we deemed earlier, but the direction which is now applicable, right?
Sir, I understand that. But what
Hmm.
I'm saying is, when we are solving questions, we never really are concerned about this. We simply say that the force will be acting upwards, and we solve our question accordingly. Right, all
I
the
do,
rod
I
moving
do
in.
agree. I do agree. Why? Because when we are letting the electron move from left to right, we are discounting on the fact that there will be force on electron owing to presence of magnetic field. We need to then understand how it's possible for electron to move this way. There must be some field which is keeping it balanced, right? It cannot discount. It is divorce of sense. It is moving this way and it has space, so it will turn, right? Isn't it?
Okay, okay. So
So there
basically,
will
we
be a
don't.
force. There will be
Sir,
a
so,
force because of the accumulation of charges. There will be a force.
हाँ जी.
Got it?
So basically, to summarize it, normally when we are solving problems, we don't think about it. But in
So
actuality, if we dive deeper into it, there is a force acting
you want
which
to justify
balances.
it. How do you justify? If you're not diving deep in it, how on earth will you justify there'll be no work done? Can
हाँ
you
हाँ ठीक
justify?
है sir. No no we
Can you
cannot
justify?
justify like that. No.
Similarly, can you justify why do we have potential for electric for magnetic field? When potential is defined only for conservative forces, are we airing that magnetic field is conservative in nature?
No no we're not saying
How?
that. That's
Why
wrong.
is it not? Proofs it is not. How can you say it is not?
Array,
What
we have
makes
been
you say
told
it is
this.
not? What makes you say it is not? Just because some statements were made. What
Yeah, I
makes
mean
you say it is not?
we haven't told this. That's why I believe it must be true.
So think about it. Yeah. This is the question to ponder. Okay. Hello, I'll be taking a fine. I'll be taking break now. Thank you. Thank you, class.
Sir, do we need to message you today for the notes?
Yeah, please. No, not today. Not today.
So the notes that you sent yesterday will suffice.
Yeah, you can share. You can share with them. You can share with the other guys.
Okay, fine, sir. Thank you.
Okay, take care. Bye.
Bye.